Greetings, Marsh here, and welcome to episode 363 of my modded Factorio playthrough. In this episode, we are going to talk about thorium, as well as make the heat shield tiles for our rockets. Enjoy. Well, one thing I'd like to touch on is maybe doing some thorium power, because I'm actually kind of worried about how much power we're using, and that this setup is probably big enough, but I think we're going to need more reactors. So one way we can make this bigger is to do thorium power, because we have this setup here, including that one right there that actually got the fuel, that burns the uranium, and then this burns the plutonium, and they're both kind of linked to each other, and thorium would be too. And so long as we have curiums available, we could turn this into thorium fuel. So we might as well. It'll have a higher peak output, and it'll just be more efficient. So let's maybe pull some things out of here for now. We'll leave those materials on there. That to do thorium power, we're going to have to research Centrifuge 3, which is components we all have, of course. And then that gives us thorium-plutonium-based power systems. And that's actually real expensive. So I guess that's a good thing that we're researching it now, because that is going to take a little while. So how do we do this? Well, first we're going to need thorium, which we're going to have to process to get. So that's something else entirely. Let's say we got it. Well, we would process the thorium ore. And from 5 pieces of thorium, we would get 4 of thorium-232 and a 15% chance of plutonium. So this is actually a way of generating plutonium without really burning anything, but it's not much. And then the way we make the fuel is we put zinc plates with a moderate amount of plutonium, a single curium, and lots of thorium to make 15 thorium fuel cells. And each fuel cell has 15 gigajoules. So if it was difficult dealing with plutonium being at 8 gigajoules, well, now we have thorium to deal with. And then when we're done with those thorium fuel cells, we can reprocess them to get resources back. And it's kind of interesting how this works. This recipe is for 5 fuel cells, whereas to make the fuel cells, we get 15. So multiply this number by 3 to compare it to the recipe that went into it. So it makes a neptunium, which doesn't turn into plutonium at a 1-to-1 ratio, but it's kind of close. But I would say it's safe to assume we would get 2 to 3 plutonium back of the 8 that went in. And then we would get 2 thorium times 3. So that would be 6 thorium of the 17 that went in. And then, interestingly, we get a tiny % chance of a uranium-234, just as a random byproduct chance. So if we so happen to acquire that, we could just turn it into fuel and burn it directly. And then the limiting factor of all of this is the curium-245, where we have a 25% chance of getting one of those, whereas we had to put 1 in to make the cell. So what it means is there's a 75% chance of getting the curium back every time. So the curium will actually last a long time. We're not really using it that fast, but it will eventually run out. And this also unlocks the advanced reprocessing recipe for the plutonium fuel. And we probably should do a refresher and compare it. Well, right now, we're putting 5 fuel cells in, getting some americiums, which basically turn back into plutonium, and a tiny little bit of curium and uranium. So this will generate a great deal of plutonium at the expense of a great deal of uranium. Well, the advanced recipe still generates plutonium, because if you look at the recipe that makes plutonium, 2 go in, and we get 20 fuel cells on the way out. Where this one is a 5 recipe, so we would have 20 fuel cells, so times 4, that the 2 went in, and we essentially get 8 plutonium on the way out. Well, this one is a times 10 recipe, so we need to multiply this times 2, so we would get 4 back, so we don't get as much of it back, but very importantly, no uranium input at all. And the limiting factor to this whole setup is how much uranium-238 we have. So if we are not using the 238 to reprocess our fuel cells, which goes into this part here, we will get a higher efficiency from the input uranium, which starts this whole process. So it's a breeder reactor that requires no 238, which is just more fuel for either the reactors or, more likely, the rockets. It makes a lot of slag. But the big part here is that we have a 45% chance of getting 3 curium-245. So instead of curium being a very rare item, now it will be rather common. So if we do this advanced recipe, To make curium, it means that thorium power will now be the primary method of power, and plutonium and uranium will just be byproducts that will occasionally run. And it also gives us a small chance of another 235, which is just more free fuel. And then the slag and fluoric wastewater as junk output. So that's the cycle. And once we do this, we will actually have a more or less closed loop cycle. It's going to be plutonium positive, but we'll use those elsewhere. But finally, our nuclear cycle will be complete. We could build this fast burning reactor here, but notice that its efficiency is only 25%, and it gets no neighbor bonus. So it's not for generating power, it's for quickly burning through fuel so you can reprocess it like this. Which, if that's something you want to do, that's what you would use that reactor for. But that's not what we want to do. Man, this stuff is expensive. But ultimately our goal here is thorium power, and we'll need a special thorium reactor for this that has 72 megawatts per reactor, and of course it gets a neighbor bonus of 100%. So this will be an even more dense method of power, which can run into issues when it comes to getting the turbines powered up, but its max temperature is not 1,000 but 1250, so we have an extra 250 degrees of temperature to work with here, which will definitely help out. And there is one better turbine that we can do. It has a higher max temperature of 765 degrees, which requires more power to get started, but once it does, it will work a little better, be more dense, require less water. And density is definitely an issue with how much power this thing creates, so we want to make it as dense as we can get away with. And one other thing, it would be nice to research if we had some slots here, but I guess we'll get them eventually, but I'll talk about them now, is we need to do the higher tier of heat pipe. That if we do gold and copper tungsten, we'll get heat pipe 4, which has a maximum temperature of 1500, which will definitely help. And then finally, we will put that into the heat exchanger, which will get the steam up to 765 degrees for use in those turbines. And that will be the maximum power density and maximum water efficiency of a nuclear setup. But for now, we're getting a lot of research, so we should probably just kind of look at things and see if there's anything we want to do. Well, we are working on better military technology, so let's see what we can do with that. We now have the better artillery, which will make the biters very angry, but it will help out a little bit. We do have one being built right here. And it looks like it's the old style with a ton of stuff there, but let's just upgrade it. So it has the same minimum range and just a tiny bit longer automatic range. It's not really much, but probably the biggest difference is that it has a shooting and damage bonus attached to it. But as far as the automatic range, it's not a lot different. Also, one thing that happened in the update was that they actually improved these higher tier of gun turrets to actually make a difference. So now the higher tier turrets do have a longer range. They don't get the same damage bonus, but they shoot farther, which is certainly a help. So I'm glad that we built them. Okay, that is constructing. They don't build very fast, but we don't need them very fast. And wow, is this set to 50? Does not need to be 50. Also, we unlocked the final tier of the plasma turret, which does all of the work defending the factory. It has a slightly longer range, it's not much. The main benefit is it just does more damage. And it's going to require a whole bunch of orbs. It's definitely a lot less orb generation now, after setting Swarmageddon down. Still makes a whole bunch, but at least it's not as massive as it was before. Okay, the orbs are here, and making the plasma turrets. We still need to upgrade the lasers, but we've got some other research we're doing now, so we're gonna have to wait on that. And of course, there's also the most of them, which will take the longest to upgrade. But let's do an upgrade here. Tier 4 to Tier 5. Oh, there's actually a Tier 3 of turret. Probably should check to see where that is. Huh, we could have made it already. Well, we'll throw it on the end then. Well, that's good to know that there's no point in upgrading what we have, because there is a final tier here. And its range is increased a little bit, but it's still not exceptionally higher than it started. But nonetheless, it is pretty good. So we might as well toss that on the end there to get done whenever research gets to that point. We can, however, upgrade the plasma turrets. So we'll just come up here. Wow, there's a lot of things there. I guess they were breaking through the wall. And the robots will get them all fixed whenever they have time. Well, we also have the better radars. Simply have a longer range and higher energy consumption. Man, that's a lot of stuff in here. Are we even making radars here? Or is it somewhere else? Nope, looks like we were building it with items from the bus. Oh, but it looks like we pulled some extras over there to be easy. Let's do the same thing. So we finished researching gold, which means we can jump in here. And normally, we could upgrade this in place. But if you look at the requirement, to do gold requires the 4th tier of Strandcaster. And we've already got them on our mall. So it means we got to get all this upgraded. Luckily, robots do all the work for us. And this is something you want to do if you can, because you get a resource efficiency increase by doing this. Not only is the machine 4 times as fast for the same number of coils, but instead of 160 items going in, you only have to put in 140. So it's an improvement. So all of these pipes should be lined up correctly now. The only thing we have to change is where everything is connected. So we'll delete the water out of here, and then that needs to be connected to the coolant. And there we go. It's filling up and running. And I suppose we'll put a pollution cleaning in here. Same thing. Clear the water out. And push the coolant forward. Unfortunately, glass could benefit from this, but not that long ago, we already built this, so I don't really want to tear it apart just to modify it to run on coolant. At least until we seem like we are running low on glass, and then maybe. Well, we've got a lot of research to go through related to our thorium power, so in the meantime, we might as well find something else to do. We don't have to wait for thorium power before we can continue. It's more of an optional thing that'll just help. Well, our ultimate goal here is to start launching satellites. So we should work on that, and of course we have our giant plan of rocket parts here. This could be broken up into 3 complex components. Or let's say large components, not necessarily complex. One is the heat shielding tiles, which will require, even if they're the fastest machines, 350 sintering ovens. We need rocket control units, which is 226. And then this giant setup, all of these stages, to make our rocket fuel. And it's rocket fuel out of trees. And ultimately, we kind of decided on 20 rocket silos. That seems like it'd be fine. Our factory could certainly put out more from a raw resource perspective. But we needed to know that number so we had a rough idea of how to build this stuff. And let's start with the heat shielding tiles, since that's pretty straightforward. It's just one set of machines. We just need to figure out where we're going to put this. This would require silicon nitride, and we size that based on 60 because we have a setup here that is doing about 30, and it's pretty reasonable for us to crank this up to 60. But beyond that, it probably wouldn't fit in this space. And then we have our tungsten carbide plates, which we need 30 of. And our setup right now actually only does 8, but that's because we were going to switch this to speed modules when we could. And it looks like all of the machines got replaced. So that is something that we can do now. So we have 60 machines here, and our goal is 60 a second, which means each machine would need to do 1 a second, and of course, it doesn't. We had these productivity modules in here because at the time, tungsten was a rare resource, but now that we can essentially create every resource we want on demand, we don't really need to do that anymore. And clearly the speed modules are way too much, so if we just do 1, even that is fine. But that does mean we can do an efficiency and a pollution cleaning into there. And actually, if we position our character right in the middle, hopefully our robot zone is big enough we can't tell what it is, but hopefully it's big enough to do this whole zone. They picked some up, so it wasn't quite as useful there. We'll have to wait for the robots to replace everything, but we'll put 1 speed module in there. And that basically does it, so we'll do the same thing of efficiency and pollution cleaning. That's probably fine. We'll just let them all get replaced. I suppose one thing we could do to upgrade our character is just give us way more robots, since we clearly can support them. But we also barely do any construction anymore, where it really doesn't matter. And this setup, even though it's running on productivities, it's perfectly fine. But we probably can do the faster modules, and then maybe a pollution cleaning into there, just because we already have a sufficient number of machines. And let's get all those replaced. And have robots finished on this one? Looks like it. So now all together, we've got more than 60. So that's 30 a second. We're going to want to crank this up to 60, or ideally even more than 60. It's interesting how the icon for silicon powder changed, but the icon that's actually on the belts hasn't. But I'm assuming we're going to have 120 potential silicon input. It's almost certainly what it is. Basically, yeah, because it's being doubled from the input. So if the input is 2 belts, that means we're going to get 4 on the way out. So we potentially could put 4 belts of silicon in here, and it's a 1-to-1 ratio to the powder. So we could actually double this up reasonably fine and get twice this if we really needed to. But we're also going to need that silicon for other things. So using half of it for our heat shielding tiles seems pretty reasonable. Of course, the big question here is, are there any better machines? And as it turns out, yes, we have a better chemical furnace. And let's just supercharge this station with 2 belts. And that will allow it to load rather quickly. And while we're here, I guess we'll give it the faster inserters. So we're going to have 44 machines, and we're going to need a nice 69 items a second, which means each machine needs to do 1.57. So 1 speed module. Nope. 2. Yep. Good there. And let's put a pollution cleaning into there. And now we know the module complement that we need. Speed, speed, and the pollution cleaning. I'm not too worried about power at this point, since we have nuclear power and all of that, and soon to have thorium power, so I'm more concerned about keeping the pollution down. And these could get productivities, but the only thing it would save is just a little bit of silicon, which hardly seems worth it. All the machines are placed, so now they can get their modules. It is annoying that we have a road here, and several roads now were built to support the tree farms. I was so aggressive at placing tree farms everywhere that I needed to put more roads down just to support them. It's actually doing a really good job in the sense where right on the bus it's dirty, but then right when it leaves the bus it's all getting cleaned away. Maybe we need like another one right here. That would actually probably help. So while I'm thinking about it, how about let's just do that. You can never have enough trees, right? Since I changed the module settings, so the pollution producing modules were better than the speed modules, now suddenly we have a huge amount of extra resources that we can put in all of this. Eventually we're going to get this cleaned up, because surprisingly they are doing a really good job at keeping all this managed. Another thing we can do is send this to the intermediates bus. Can't tell if that's silicon nitride or not. Actually, we could just teleport here. It's silver nitrate, where this is silicon nitride. I'm just thinking this might be something appropriate for the intermediates bus, but then kind of the problem the intermediates bus has doing everything else is it becomes incredibly polluting in this one spot. But we do have an enormous amount of space right here with way too many robot zones. Well, one thing we can do is just attempt to build it here, see how big it becomes. So this gives us 27. So we can actually get 40 of them in a giant impassable line. And that's actually fairly reasonable for the number of machines we would need to make. It's just the amount of pollution in this one spot is going to be bonkers. But we could always put more farms, like we could put a farm here, we could put a farm here, and just stack the farms as tightly as we need to until it's controlled. Well, to make it as dense as possible, we would probably just want to have one belt going in and one belt going out. So one machine has an input of 0.2, and 40 machines on each side is 80. So we would need 16 resources per second of the silicon nitride, which means it would have to be purple to have the correct throughput. And then the output, of course, could be just the yellow belt. Okay, we should now have something that tiles and looks nice. Man, this is a lot of copies. All of these robot zones we don't need, but that gives us 80 of them, and we could potentially put less of them in here once we've got them all placed if the shape is just a little too weird. So we select everything. We have 80, 160, barely even zoom out enough to see. So that's 240, and then 320. And let's just get rid of all these robot zones too. Let's get one more in there, like that. We'll figure out those holes in a bit. We just need to see, does that shape make sense? Well, it basically takes up the rest of the bus, so probably. We wouldn't really want to make it any wider because we want to have room for farms and more farms on the side of this. And in fact, I'm thinking we might want to preemptively do that. But anyway, we have 400 of them, which means we need to get rid of a few. About 50. So we good now? Yep. That is quite the setup. Because of this quantity of pollution, I think we're going to need a few more farms. I wouldn't normally want to stack them so close together, but the pollution is so bad. So you don't really want to put farms right next to each other because the pollution needs to kind of feed in from all sides. If you put them right next to each other, like right here, then the pollution can only come from the edges and not like up and down here. So we at least want to have a little bit of space. So that would be a space. Let's say, let's make that one a space. So if we put one here, there'd be some more spaces there. So yeah, how about we do that? Which does kind of space them out. How about in that slot there? We are really making use of all of these. We have all of those Bitafran farms, so we might as well put them to use doing something. Okay, well we're going to need all of those resources. The silicon nitride and the tungsten carbide plate. There we go. Should come soon. It's not great for logistics doing it this way, but just for space reasons, it didn't really make much sense to put that giant setup over here somewhere. Not to mention, it's actually a fairly short train ride to go up there. Looks like we're not building any more arboretums. And why is that? It's got everything it needs, but it looks like the requirements are different now. Not sure why. Well, the mods were updated, and some things were changed, so that gets the arboretums updated. So hopefully they'll be good now. And actually these numbers are so high, it actually needs to be a purple belt. Which is a little annoying, because we're starting to max out our belt logistics here. We can get more, we just have to order a second train and use up a new slot. Well, I see our resources are arriving. Which means we are just about at the point of being able to test this. We just need to wait for all these machines to actually be placed, because our mall does not actually create machines particularly quickly, because it doesn't need to. So whenever we have big setups like this, it takes a little while for them to get built. But the tree farms are firing up here, which is fantastic. That is a lot of pollution reduction right here. Even though this creates a lot of pollution, the extra farms we placed here actually easily will counteract it. And I am eager to use that thorium because we're actually continuing to build up some curium here, so we're definitely at the point where thorium power is relevant. And our uranium setup is slowly starting to fire up. It's never really going to go at full power, but it's starting to go. And hey, look at that. That's a couple more uranium reactors that are going. They're not the test reactor, of course, but that's 3 of the 12 that are going. We only get an indicator here if this one is on, but we are creating a lot of nuclear power in general. 9.4 gigawatts. That's quite a lot. Whoops. I just noticed here, because a robot so happened to crash here, I put no limiter on these radars, so now we have way too many of them. But in this situation, because we actually need to put a couple of them into each satellite, that we'll actually use those eventually, so... Oops. Oh well. That at least is less of a mistake compared to making, I don't know, 600 electrolyzers that might never get used. One other thing that occurred to me, it's probably a very small optimization, but on our science bus, ultimately we are being left with extra resources that we can't consume. Well, clearly we are burning the butane and the ethylene. The butane makes sense because we currently can't do anything with it. So I'm actually wondering, we could put these on drones, since our plastic setup here already keeps this stuff on hand. We have an ethane tank and a methane tank, and technically a butane tank. That why not just send them on drones, since it's relatively small numbers, and put it into this setup, and then let this setup deal with them. That would end up being slightly more plastic than just burning the extras right here. So how about we do that as a small optimization? So first we'll pick these three up, and then we need to put supply tanks down, but we need to put limiters on there. So we need to do 3 riders, but we also need 3 readers because you have to put a reader on one of these fluid depots. It doesn't work like it does on a supply depot. And all we need to do is say, whatever we have has to be more than 1,000 for the thing to turn on. Let's actually unhook the setups. And actually it looks like we had methane unhooked. So it was going into things. We have it unhooked from that setup too. Ah, I see. We were turning the methane into fuel blocks, which makes sense. And that's if it gets above a certain number, which also makes sense because those are the control tanks. But now we've got thousands of resources in there. Let's see if we can put them to use. I think we will be able to dump these into our plastic setup, and it won't just completely destroy the logic. I think the logic is flexible enough to where it will work, and luckily we can just barely fit this in here. And there it is, making all 3 requests, but we probably want even more drones on each one. And we'll just have to check back here and make sure that this doesn't break it. But it shouldn't, because certain resources are limiting factors, so it won't really matter. They'll just get consumed as dictated by the logic. But we'll see. It very well could be a very carefully balanced setup that is very easily broken. Okay. Every machine is placed to make our heat shield tiles. Let's check the whole stack. Make sure our numbers look about right, and yeah, they do. So I think we're ready to go. We hook this in. And then the other one comes in through the other side. And yeah, these machines, they do have a glowy light on the side. But that's about it. They don't really move on the outside, so it's hard to see that they're doing anything. They also don't make much noise. But they are running. And we are still pumping out a full belt on each side into this. And there they are. They're pretty small, but we're making them. Ultimately, we only need like 12 of them a second anyway, so we're not going to see a lot. But also, this setup is so long that it's actually going to take a long time for all of these machines to get properly seated. But they are. I mean, they're going. Well, they're starting to get populated here. The resources are still getting dumped in. Well, and they always will with silicon nitride, because that's ultimately the limiting factor. But the heat tiles are starting to build up, and the electricity use is starting to increase. That this thing is going to take, what are we looking at here? 771 megawatts while it's running at full power. So it is going to be significant in itself. So you kind of see all these setups that are all almost a gigawatt or more each, where I'm thinking, we probably need more power. We need our thorium, because this is becoming increasingly power hungry for all of the things that we need to do. Okay, the tiles are building up, so let's take them to the train stations. It'll go through an LTN dynamic station like everything else. Hopefully we have another slot. We do. Fantastic. I wonder if there's any other components of the satellite we would want to make elsewhere. Like, for example, we can make the RTGs in a different location and send them in. Or would it be easier just to send the plutonium in? Honestly, since the rate of production is so slow, we could actually build this right next to where the satellite's being built. And since we need so few machines, the satellites will actually be built right next to the silo. So we could just do a little mall or whatever right next to every silo that will bring in all of the necessary resources that aren't already on buses and needed in huge quantities. But looking good. Pumping out the heat shielding tile, probably making a huge amount of pollution. Oh yes, in fact, let's fly over there. Or better yet, let's teleport. Here we are, to see how much pollution it is. It's actually not that much when you consider the massive amount of pollution this is creating, and then how hard of a time it's having going anywhere. Because it's flanked by all these farms that are actively running. It's actually funny that this farm, despite the fact that it's going at full blast, there is 100 pollution here, and it's increasing. Because it's actually producing more pollution than that one farm can handle. But otherwise, looking good. And that's the end of this episode. On the next one, we are going to work on making tier 4 ore mixtures, so we can sort that into thorium ore. Thanks for watching. I'll see you later.